The Wilcoxon sign rank test is the one-sample non-parametric test based on the ranks of the data. It can also be used for two-sample paired testing. We will talk about that next week. We will create the differences by subtracting the hypothesized median value from each observation. Let's talk a little bit about the ranks of the data. The rank is the integer value assigned to an observation based on where it falls within the remaining observations when they are ordered smallest to largest. So the smallest observation will be given rank 1, the second smallest will be given ranks 2, etc. If there are observations that have the same value, the average of the ranks is assigned to each observation. Let's do an example. Let's determine the ranks for the dataset given in the slide. First, we need to order the data from smallest to largest. Now assign integer values from 1 to n for each observation. Since we have two sets of ties, we will take the average of the ranks and given each that value as the rank. So there are two 4s. The ranks would be 2 and 3. So we find the average of those ranks, which is 2.5. Now we assign 2.5 as the ranks for both of them. We do the same thing for the two say xs. Since those ranks would be 5 and 6, we take the average 5.5 and assign that as the ranks for those observations. To prepare the data for the Wilcoxon sign rank test, we need to transform the observations by using the absolute differences between the observation in question and the hypothesized value as seen in the slide. We will then omit all of the differences that equal 0 and let the count of the remaining number of differences be considered n. Now we will assign ranks to the remaining n absolute values of the differences as seen earlier. Let's look at assumptions. For this test, we should assume that 1. The distribution of each d is symmetric. 2. The d are mutually independent. 3. Each of the d have the same mean. 4. The d's are continuous. Notice that this means that this test works only for continuous symmetric distributions. Otherwise, we should be using the sign test. Here are the hypotheses for this test. The null hypothesis is that the median is equal to some hypothesized value. The alternative will be either less than, greater than, or not equal. Here is how we find the test statistic t plus. 1. Find the differences for each observation. 2. Determine the ranks based on the d. 3. Determine the value for re by adding the sign of d to each of the ranks. Now the test statistic becomes the sum of the ranks where the differences are positive. The random variable t plus is discrete, so we can find the distribution directly. This is done by 1. First find the range of possible values that t plus can take on, support of t plus. 2. Determine the probability that t plus takes on each of these values. Let's first focus on the support of t. 10. Minimum t plus could be 0. This would occur if all of the observations fell below the hypothesized median value. Maximum t plus could be n, and plus 1/2. This could occur if all of the values were larger than the hypothesized median value. T plus becomes the sum of the integers from 1 to n. There could be many other possibilities for t plus, even when n is somewhat small. Determining the exact distribution gets tedious even for 4 or 5. There are some tables available to do this. We will typically use the normal approximation since we are assuming that the distribution of the differences is symmetric anyway. Here is the approximate test. Notice that this is a form of the z statistic. We will assume that the test statistic follows a standard normal distribution. Here are the alternatives and how to calculate the p-value and build the rejection region. Notice that for the less than alternative, we need to take the negative of the test statistic. Here is an example where an analyst would like to see if the median visit time is less than 22 minutes. We have a sample of 20 visit times. Let's look at the data. You can see here that there will be no ties. Also, there will be 5 positive ranks and 15 negative ranks. This is because there are 5 observations that have values greater than 22. Here is a table of the calculations for the first 10 observations. Notice that we find the differences, then take the absolute values. Now we find the ranks based on the absolute values of the differences. Then we add the sign to the ranks based on the sign of the original differences. Here we have the calculations for the second set of 10 observations. To find the test statistic, we will sum the positive ranks. The sum of the positive ranks is 38.5. Now we can use the approximate test to get the p-value. Here are the results for the approximate test. Now we can use the test statistic along with the less than alternative to get the p-value. The p-value is 0.007. Let's draw conclusions. Since 0.007 less than 0.05, we will reject the null. There is enough evidence to conclude that with a 5% error rate, the true median visit time is less than 22 minutes. The Wilcoxon test has more power than the t-test when the data is symmetric, but not necessarily normal. The Wilcoxon test is more powerful than the sign test when the data comes from a symmetric light-tailed distribution. Otherwise, we should choose the sign test. So what should you do in general? 1. If the data is normal, use the t-test. 2. If the data is continuous and light-tailed but non-normal, use the Wilcoxon. 3. For any other situation, use the sign test.